All right, let's talk about how to use this Vernier Video Analysis program. I'm going to go ahead and import a video. I'm going to import a blue car that's traveling to the right. And so this video shows the car moving to the right there. Nothing too exciting. I'm going to go and analyze this motion. So I'm going to bring it back to the beginning. And this video has 192 frames. It's a lot of frames to look at. So I'm going to go ahead and I'm going to change the number of frames to, I'm going to do it every 10 frames. That'll give me about 19 data points. About 19 data points. What I'm going to do is I'm going to show the computer where this car is at on every frame. So I'm going to go ahead and pick a part of the car that is very easy to look at, that stays the same throughout. I am hoping that this antenna, let's see here, let's watch this car. Looks like the antenna is kind of moving back and forth, so I'm not going to use the antenna. I'm going to use the center of that wheel right there as a point to show at every frame. So I'm going to click the center of that back wheel. The car goes forward 10 frames. I'm going to click the back center of that back wheel again. The center of the back wheel again. I'm going to keep on doing that. And I'm showing the computer where that car is at every 10 frames. And this is kind of fun, kind of therapeutic here, kind of stressful too, trying to get that center of the wheel every single time, but kind of cool too. All right, so showing the center of that back wheel right there, right there, right there, right there, and right there. I think that's the last one. Okay, so what you can see right here is it shows the position of the car at every 10 frames. I'm gonna look at just the X data, not the Y data. So it looks like this car was kind of moving back and forth a little bit. I'm looking at just the part that's traveling to the right there. I get this graph that looks like that. As you can see, this shows pixels versus time. I'm going to go ahead and change that to meters by using this tool right here called System. I'm going to go ahead and make the length of that equal to 1 meter, like that. And as you can see, I've got a position versus time graph. It looks pretty darn linear. I'm going to go ahead and highlight it. I'm going to apply curve fit like that. And you can see that because R equals 0.999, when R is equal to 1, it's like a perfect fit. This is real close to 1, so it's really close to being a very, very, very good fit. I'm going to go ahead and get a model from that graph. And I can see that graph right there is linear. So because of that, I know that Y equals mx plus b. Since this was along the x-axis, I'm going to go ahead and call this x, like that. Our slope is 0.17 meters per second times x. In this case, x is t. Looks like our y-intercept is 0.31. Is 0.31. So plus 0.31 meters. So that right there is our model. It's our model right there, and it gives us a model which allows us to predict the path of that car at any given time. And of course, it's fun to talk about the meaning of that slope and also what the y-intercept means. So to analyze the motion, we go ahead and use this add points at each of the points, and then make sure and use this system to go ahead and show the computer the length of a certain number of pixels, basically to calibrate the computer so it knows how many pixels are equal to how many meters. If you do those things, you should get a nice looking graph. From the graph, you can make the model. All right. So good stuff. All right, physics.